Welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is Introduction to Wire. In today's webinar, you'll learn how to program inside, outside, and open 2- and 4-axis wire cut paths. As you know, my name is DePoalo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at DePoalo, or you can also search hashtag BobCAD After Dark. So what are you going to learn today? Today we're going to talk about CAD preparation, different ways to prepare your geometry, basics about moving, rotating, things like that. We'll set up a job, go through the stock and material. We'll talk about different geometry selection options that you have. We'll go through the wire wizard, so the different 2- and 4-axis wire paths that we have, and then through some simulation options. So when we're looking at CAD preparation, we'll talk about measuring geometry, converting surface edges to wireframe, doing projections, moving and rotating, things like that. We're also going to talk about, using wireframe, using loops or constant Z of surface edges to do your selection. We'll look at both 2- and 4-axis, inside, outside, and open examples. I have about 10 different part samples that we'll go through. Let's see what else. And we'll also get into simulation. There's some pretty cool options in simulation that is very useful once you know what they are and how to use them. And as always with BobCAD, you got fewer steps, better cuts, and more profit. So give me just a moment to get my screen up and we'll jump right into the webinar. While we're waiting, if you... why don't you just do a shout out of where you're from, just so I can get an idea of where everybody's from here today. So in the questions box, you can type in different things. It's real important to me. I really like to get a lot of feedback from you guys. So any questions that you have at any time, just go ahead and type it in the question box. Let's try to keep it on the BobCAD subject and wire, because that is today's webinar, but definitely any questions you got. We got Russ from Minnesota, Danny from Arkansas, Robert from Gilroy, thank you so much. Mike from Gilroy, Robert from California, Jeff from Mexico, thank you so much for coming, Robert from Michigan, Tom from North Carolina, Richard from Pittsburgh. We got Richard from Illinois, Nick from Iowa, Charles from South Carolina. Thank you, everybody, for spending some time with me here today. Matt from the UK, Ronald from Ohio, Stefan from Germany, Stephen. Again, I just want to thank everybody for coming here today. Now, while I get going here, if you could also, just a quick question, if you guys are running... if you're running a wire, if you're running the BobCAD wire software, just go ahead and write in what version you may be running, whether you're running 19 or whether you're running 26 or 27. If you're not running the BobCAD wire software, just go ahead and comment not using the BobWire. Okay, if you could do that for me, that would be great. And then the other thing that I would like to know too is if you can tell me what controller you're running on. So whether it's a SODIC, a JPEX, whatever controller that you may be running on, just go ahead and comment that in there as well, just so I get an idea of what kinds of machines you guys are running. And then also what version of the BobCAD software that you're running. Now, as you guys know, BobCAD is CAD and CAM, so we can import, edit, design, and machine. The BobWire software supports 2 through 4-axis wire EDM cut paths. And all right, let's go ahead. While you guys are commenting on those questions, let's get into it. So the first thing that I have is I just have a really common, this is a 2-axis wire path that I have set up here. We have land and taper. And the first thing that I wanted to go through is when you have a job set up, you have your job in the tree, you have your machine, you have your stock set up, you got your machine set up, and then below that machine set up, you have different features. Okay, so this is just a 2-axis inside shape. We have a rough cut, a skim pass, Probably should have a tab in there as well. But let's just look at the backplot function. So if you go over any of the operations, the rough cut, the skim cut, the tab cut, if you right click on that and you choose backplot, what this will do is show the wire, and then what you can do is click through this so you can see what's going on. All right, so a couple of things that you may, hotkeys, S for shading. If you click S on your keyboard for shading, that will turn the shading on or off. If you hit T on your T as in Tom or transparent on your keyboard, that will show you the transparent view. If you smash or press your center mouse wheel, that will get you to a rotate. So again, backplot is just a really easy way for you to click through segment by segment to see where the wire is going to go. We can do that for the rough cut. If we right click on that operation and we go to backplot, and we click through this, again, you'll be able to see the land that we have here. Okay, so this is just one of the visual aids that you get so you can see what is going on. Danny had a question, what version am I demoing? I'm demoing the version 29 wire software. And again, if you're just getting in, if you haven't mentioned what version of BobCAD you're using or not, and then also what control you're using on the machine, whether it's a Sodec, JPEG, or whatever machine that you might be using. Okay. Now, so we did a little bit about the backplot there. Now, the next thing that I want to look at here, so you have S for shading, T for transparent. You can go over any operation, right-click, backplot, and you can plot through to see where the wire is going in what direction, okay? The next thing that I want to look at is simulation. So we'll go modules and simulation. So we're going to just load up the simulation. Any of your toolpaths that you have on the screen that are postable, like you don't have them turned off, they'll show up in simulation. You will notice that I have, there's all of these simulation options that are available. My personal preference is I turn these all off and I only use the ones that I want to use at that time, okay? So when you're in simulation, there's a couple of things that you're looking at here. If you go to visibility, the workpiece would be any solid models that you have on the screen, and then the stock would be your stock geometry, and you can change this to transparent so you can show your part model, and then you can do transparent stock, okay? So that's a useful way to see what's going on. You can step through this routine here. If you step through it line by line, you will see where the wire is going. If you have machine simulation, it will show the wire heads. This way you can see where the wire is going and what it's doing, okay? So again, that's just a little bit about simulation. The two key points here is your workpiece is any solid models that are on the screen, and then your stock you can change from show to transparent. And that's really all I want to look at for simulation right now. The next thing that we have here is you can post out a setup sheet. So if you right click on your job, you can do generate setup sheet. There's a couple of different options. Any of the CAD display when you launch the setup sheet will show up on the screen, so you can have a top view or a side view. You basically are going to see the different operations here, and then based off your feed rate, you'll get some cycle time, so you have an idea of how long that job is going to take to run. Okay, so that's a little bit about the setup sheets. And then the other thing we have here is posting. So if you go over the job, you right click and you choose post. The posted code will come up in the posting tab. The other thing you can do is post and save as. So that's another way to go, where you can right click and do post to save as, and it will save it to a directory. I generally will post it in this window first so I can see what's going on in the code, and then I can right click and choose edit to launch it in the editor. Okay, so that's a little bit about the posting as well. Now you can the format of the code is going to be based on what machine you're running. So if I just right click and change this, maybe I'll change it to an AGI machine, and I'll go ahead and post that up. I can repost this job for an AGI. If I change this to, what are some of the more common ones? Here's like a RoboFill. So I can post up that code. You can see the format of that. We have a rough cut and land cut. A straight cut and a taper cut is basically what that is. All right, we're gonna Oh, let me get out of there. We can go to the machine and change. So maybe this is, maybe you just have a Fanuc style. So we can grab a Fanuc style and post that up. And you can see, again, depending on what machine that you're using, it's going to format, it's the machine and post processor. Now, depending on what machine that you have, there are different options that are set or not set. Are you posting where the guide heights are? Are you posting, how are you handling cutting conditions? Are you running in subroutines? So, a lot of this is going to be based on your post processor, but then also your current settings. We have all the standard machines pretty much set up. There may be some customization that is needed, but you would work with the support department to get some of that in there. So that's just a sample program, a couple of different formats of code, just so you can kind of see the difference. And then, also just some of the basics, like you have the job and backplotting and simulating, etc. Okay, so if there's any questions about that at this time, go ahead and ask it. Let me see if there was anything else that had come in and that I might miss. Now, here's the thing. If I miss your question or I don't answer it, I do apologize, but I do write a Q&A wrap-up after the webinar for all the question and answers, and a copy of that will be emailed to you. Also, there'll be an emailed copy of the video. The video will be sent as well, so you can watch it later. Let me see here. I make programs other than Sodic. Create my own post and ECC database, not for Sodic. Okay. All right. Very good. Missed the setup sheet. Can you show it? Yeah, Danny, if you just right click on the machine job here and you go generate setup sheet, it will create a setup sheet for you. Where can I get the FA posts that you have? The posts that I have are all either came installed with the software or were downloaded from our support page. So if you need a post processor, you can log into the support page and you can download it from there. Hopefully that showed what you're looking for, Danny. And I think that's about it. So let's go ahead and let's get into our next file here. So, as with anything, CAD preparation is really your first step. I know I'm working with some solid models here. You may have a DXF. You may have a DXF file just here. Okay. All right, Gordon, no problem. So you may have a DXF file, you may have a solid model, but either way, you may need to move or rotate or things like that. A couple of things that are important to me is if you go to Preferences and Settings Part, you can turn on or off the axis and gnomon display. This would be the world coordinate system for the drawing. Generally, I like to have them off when I'm in programming. Sometimes I like to have them off when I'm doing design work. But again, if you just go to Preferences, Setting Part, you can turn these on or off as needed. Okay. The next thing that I'll talk about, again, is just rotating. This part came in from another CAD package, so I need to, what I generally do is the top view, I like to align the part so that the top view matches your setup view, your first setup view. Okay, so in this case, you can see this part is not in that orientation, so I'll use Utilities and Rotate. I'll click on the body that I want to work with. Now, from here, I can set a rotation position, so I could have it rotate from the 0 position and be able to rotate the geometry. Or the other thing I can do is I can move that 0 position. So I could take this and actually snap it to the model, like maybe this bottom corner here. Okay, and then I can use my rotation handles to be able to rotate it down off of that. So when you're rotating, you do have this dynamic rotation tool here, and you can align your rotation center to wherever you want on the part using your snap points. Okay, so in this case, what I did is I rotated the part flat, so now it's in the top view. Okay, the other thing that I might do from here is I may translate this. Translate is just a word for move. Again, you get this dynamic handle. You could drag this along X. You could drag it along Y. You could drag it along Z. So that's you're in a delta mode right off the right at the beginning, and you could drag it where you want. The other thing is the 0 position, where the the dynamic handles are located is at the center of the part. So I could take this and actually just snap it over to the 0 position. And now you can see the center of the part is right on 0. Okay, so a little bit about rotate there, a little bit about translate. Now, in recent versions, we've also added this snap grid. You can see that there's this magnet down here, and then this value. You can turn that on or off or change what that value is. That way, there are snap points in the background that you can pick as well. All right, so that's a little bit about translate and rotate. The next thing that I want to talk about is creating wireframe. So there's a lot of different ways that you can create wireframe from a model. Anytime I'm creating wireframe, after when I'm working off of a solid, I will create a new layer and make it active. So I put the wireframe on one layer and leave the solid on another layer. From here, I'm going to go to utilities, extract edges single. Okay. When I do extract edges, I can pick on any face or multiple faces and just convert that geometry from surface edges to wireframe. Okay, so that's one of the ways we can do it. Another thing that you can do here too, like there's a taper on this part, so I can use this. If I extract again for this bottom face, you'll see there's the geometry on the top and the geometry on the bottom. What I'm going to do, guys, is I'm just going to turn these two off so we can just look at our geometry here. So, okay, so I can extract geometry in different locations. You will notice this project to Z plane. This is a very useful feature as well. I'm going to say project to Z 0, and I'll pick this bottom face again, and then hit my space bar. And what you'll see now is it moved that geometry to 0. Now, I need to do it for the top as well, because I have the 0 is in the middle of the part. So I can say pick the top, go to 0, pick the bottom, go to 0, and then what that will do is give me both those sets of geometry flat in the XY plane. It's helpful to have it flat in the XY plane because then I can edit the geometry without having to worry about any issues of geometry being in different planes. Now, because I extracted both faces, it's very likely that I'll get double entities or geometry on top of geometry. If you want to clean that up, there are some tools to get rid of double entities. You can do utilities, reorganize, erase doubles, select all your geometry, and that will get rid of the doubles. Okay. All right. So extract edges with projection. Now, when you're dealing with your wire paths, you're going to need like a start point for like inside shapes. You may use a start point for outside shapes too, or open, but definitely with inside shapes. So what you may do is you may draw a hole location. So I'm just going to sketch one right there. Okay, so this is good. That's going to say where I would drill my hole location. But you also want to snap a point to the arc center. So we'll go point, arc center, and really you could just draw a point, but I think it's helpful to have the circle there so you can see the diameter of the hole that you're starting in. But you definitely want to draw this point in the center of this circle here, because you'll use that later when you're setting up your tool paths. Okay. Another thing that I want to talk about is section view. If I bring this model back up, you may need to measure what the draft is, or measure different aspects of the geometry if you don't have a print. So we're going to do views, section view. We'll go to a front view, generate wireframe, and then what that does is it generates the wireframe for me in this orientation. What I'll do is I'll change to my front user coordinate system. I can come in here and extend some geometry, and I'll see, okay, that's a 3-degree taper there. The other thing I might do, let me see here. The other thing, I may measure the land. Okay, I can see what the land is. I may measure what the width of the part is, so I can measure the width of the part. All that information will show in the measure entity window. Okay, so that's a little bit about section view and how you might use that. Okay, all right. Did some measurement. Some of the other things that you may get into when working with solids, most of the part geometry I'm working on here today is very straightforward, but you can get into more complex geometry. If you're getting into more complex geometry, you may need to unstitch the model and extend surfaces and things like that. So if I'm going to unstitch the model, generally I'll make a copy of it. So I'm going to just Control C to copy it. Control V to paste it. So I have a copy of this. Then I can come in and use stitching, unstitch solid to surfaces, click on my body here, and then what this does is gives me all my individual surfaces, okay? The reason why I might do that is I may isolate some surfaces here, like this one right here. I may isolate that. Okay, so I have this surface, and then, I could start editing that surface. If there's a bunch of holes punched through it already, you would untrim the surface, and that would give you the original one. If we want to just extend it, we can do extend, pick an edge, give it a value. Okay, so this way, depending on what you're working with, you may need to extend some surfaces and intersect with other geometry to get some of the profiles that you're going to need in order to program. Okay, so that covers a little bit about that. Just a quick tip. If you guys are struggling with any of the CAD features that I'm going over here, or if you're really new to the CAD, just comment, I'm really new to the CAD. And then what I'll do is email you my getting started CAD video that I've done, and it will cover a lot of the things, just general navigation. Okay, if there's any other questions about some of the CAD tools and CAD preparation, go ahead and ask them now. Let's see here. Do you need to have a part drawn in 3D to get a taper, or can the path be created with just a 2D drawing? Linda, you can do a 2D drawing, so that's not a problem at all. I have solids here because it's easier to see what's going on, but you can do land and taper just based off of wireframe, flat drawings. You can do 4-axis programming based off of flat drawings as well, and I'll get into that. If there's any other questions about the CAD tools, Tom, if you have one, go ahead and ask. Otherwise, we're going to move forward to the next batch. And again, if you're just getting into the webinar, just go ahead and post up what version of BobCAD you're running, if you're running a version of BobCAD. If you're not, for a wire, just say I'm not using BobCAD. If you are using BobCAD for a wire, just write whatever version you're running. If you're also coming in now, and I would like to know what wire machine you're using. So if it's a Sodic or a JPEG, whatever machine it is, just comment what machine you're using so I know what's going on there. All right, so that's all I have for the CAD sections. A couple of guys new to CAD, I'll make sure to send that over. Has wire changed from 28 to 29? I didn't really do a comparison for you, Danny, but yes, the software has evolved in different ways, but I can't tell you specifically right on this webinar because that's not what I'm prepared for. Okay, so let's move on to the next file. So let me close this one out. And again, any questions that you guys have at any time, just go ahead and ask them. They're all good questions. So, all right, when you're dealing with wire, we have a couple of things that you look at. You look at inside, outside, and open, and whether that's 2-axis or 4-axis. So what we have is just a really simple shape here to start with. And again, it's drawn as a solid, just because solids are really common, but we could work with wireframe as well. What we want to do is get into this job. Now, so we're going to go to the CAM tree. And inside of the CAM tree, this is where you create your job. So you're going to right click anywhere in here, and then you're going to do new job. Okay, because it's a wire job, we're going to choose wire EDM. And then from here, you can pick from the list of different machines that you may want to work with. I'm going to jump back and forth between a few different machines, but we'll go with this one to begin with, and then we're going to run our stock wizard. Okay, so we create a wire job, and then we start the stock wizard. The next thing we're going to do from there, workpiece, this would be the part geometry. If you have a solid model, you can select that as your workpiece, and then we can choose next. When you have your stock type, you could be dealing with in-process stock, you could be dealing with rectangular stock, could be cylindrical stock. There's a couple of different options. If we do rectangular, what it does is looks at the minimum maximum of the part geometry and creates a box around it. And then, of course, you can always offset what that box is, so you can add more stock if necessary. If we do cylindrical stock, what it's going to do is just put a cylinder up on the screen, and you can make that bigger or smaller. You could select sketches for your stock. You could select a solid model for your stock. Maybe you turned a part, then you milled the part. Now you need to wire the part. You could save out STL files from your simulation and be able to use that as in-process stock. Okay, so a couple of different types of stock. We're going to just stick with rectangular in this example. The next thing that we're going to look at here is our origin. Now, our origin can be anywhere on the part. In the machine setup, really we're setting where our 0 may be, okay? Danny had a question. Can you skip the stock and just program the wire path? I get a lot of questions from users that say, hey, I don't want to set up the stock. What you can do is create a template file where you've already run the stock and you've already set where the 0 is, and you can merge in your geometry. So that way you don't have to go through the stock wizard every time, Danny and any other user that has that question. And if you need more assistance with that, we can do a one-on-one demo later, and I'll go through that. But where we're at right now is setting the origin. Now, here's the thing with the origin. The origin is your 0. Sometimes the wire feed hole is going to be your 0. Sometimes it's going to be some position, the bottom of the part, top of the part, wherever it may be. If we hit S on our keyboard, you'll see all these points are drawn on the screen. A lot of CAM systems will put little buttons that you can push all in the screen. It's really confusing. BobCAD, we put the points up on the screen so you can pick them. You can also pick other points that you may have drawn. In order to set the origin, you click on origin. Now here's the thing, if I just click my mouse out in space, it'll pick a position out in space. Don't ask me why it will let you do that, because I can't see a reason why, but it will. So what you want to do is when you click origin, a lot of times you want to snap off some geometry. You can see when I go over an edge here, it highlights it. I don't have to try to click exactly on this point. I can click on this edge close to that point and it will snap to that point, okay? If I want to set a different position origin, I can click on this edge closer to the point on the bottom, it will snap to the bottom, okay? So that's a little trick to make sure you're grabbing your zeros where you want them to be. You know, again, just closer to the point, click on that line, it's going to grab it. If it's not the stock bounding box, you can also pick off the geometry as well, okay? If it's in a different setup or different orientation, you can change the axis orientation with these buttons here, set X, set Y, or set Z in order to align for a part that is out in space or what have you. I'm just going to pick the bottom corner here as my 0. That's fine, and I'll choose OK. All right. Now, again, S on your keyboard for the shading and smashing or pressing the center mouse wheel to get to a rotate. If you do have a 3D connection mouse like I do, you can use one of those as well, okay? All right. Let's see, material. Okay, so we've set up the job. We have a machine which has a post processor. We ran the stock and set our 0 position. The next thing that we want to set here is our stock, okay? Now, it's either going to say a material here or it's going to say like not connected to database. Either way, you want to right click on this and choose edit. And this is where if you have a cutting conditions database, you can pick through this cutting conditions database. If you don't have one connected, or if you're not using one, then really you're going to just use this to set the wire diameter that you want to work with, okay? Can you see a snap to intersect? No, Mike, you cannot see a snap to intersect. But if you have two intersecting geometry and you move your mouse close to it, it will grab the intersect. All right, so again, we're setting our material. If we have a cutting condition database, we can pull up one of these. If the other thing we're going to do here is set our wire diameter, what diameter we're going to cut with, okay? All right, so we got the job set up. We got the stock set up. We got our 0 set up. And then we also have our material and wire selection set up. Okay, is there any other questions about that, setting up this job and what we've done here? No? Okay. If you have a question, go ahead and write it in there. Now, okay, so the next thing we're going to look at doing here is we're going to look at just doing a 2-axis straight cut here. When we get into the CAM tree, what you're going to see is we right-click anywhere in this window, okay? So we right-click, and then this is going to give you, I'm sorry. Okay, I got stuck on the stock. We right-click in here, and this is going to give you all of your different CAM functions. Now, you can right-click on the machine setup, or you can right-click within the window, and what you're going to see is you have 2-axis inside outside open, 4-axis inside outside open, okay? So these are your different groups of toolpaths, whether they're 2 or 4-axis, and then it's either inside outside or open. 2-axis, inside, outside, or open, 4-axis. Now, in this example here, we could do an outside cut around the outside of it, and we could do an inside cut along the inside of it, or we could do an open cut just along one side, okay? So let's look at the inside shape first. So we're going to do 2-axis inside, okay? From here, we're going to select geometry, okay? And when you're doing geometry selection, if you're working off a solid, you can right-click on the edge and choose Constant Z, and that will select the profile, okay? So that's one way to select the profile. What I'm going to do is, I'm not concerned with the settings right now. I'm just going to compute. This one gives me an inside cut. Let's do 2-axis outside, select geometry. This one, what I'm going to do is right-click over this edge, and I'm going to choose loop. Okay, and when you do a loop, really what it's doing is it's previewing 2 loops. There's this loop here, and then the one along the top face. For us, we want to click the one along the top face. Spacebar, we'll go ahead and compute that one. Okay, so we have an inside cut set up. We have an outside cut set up all the way along. If we wanted to do an open setup, we'll do 2-axis open, select geometry. That might just be one of these edges, and we'll go ahead and compute that one. Okay, so here you can see we have some different wire shapes, wire paths going on. If we go over any of our operations and we choose Backplot, we're able to see where the wire is going, okay? We go over this one, right-click, we choose Backplot, we can see where the wire is going, okay? Right-click over this one and we choose Backplot, we can see where the wire is going, okay? So, first thing that I want to talk about is changing where it's leading in from. You can see that it's leading in from over here on the inside, over here from the outside, and on this open side, we're not sure which way it is just yet, okay? When you click on geometry here, it highlights the geometry, and then it shows you with an arrow where the start point is. So that would be where it would lead in from, okay? So if we right-click on that and we choose reverse direction, okay? Reverse direction will just switch what direction it's going in, okay? So if I go to this open one here, you can see that it's going from left to right. If I right-click and I choose reverse direction, you can see it's going to go from right to left, okay? So that's a quick one on reverse direction. The other thing you're looking at here is if we want to move it, we can right-click, modify start point, and we can click on any of the, what it does is actually it picks up all the snaps. So it's either middle, end, 0, 45, 90. These are the standard snap points, okay? So you can get an idea of different places that you can put this. So we can move that to a different location. You got a space bar to lock it in, recompute to update the toolpath. So that one moved it over to here. This one here, if we wanted to move this one, right-click on the geometry, modify start point, click to a different start point location, space bar to lock it in, and then you got to right-click on the feature, recompute the toolpath, okay? So that's how you move your start points there a little bit. Again, this is just 2-axis cutting. Let me go ahead and delete all these features here, okay? And we'll look at this again. Let's say we had wireframe. So I did that off the solid. Right-click for loop, right-click for constant Z. Let's go ahead and extract edges. We'll pick this this face here. Okay, so let's say we just had the wireframe like you see here, all right? So we're basically going to do the same thing. You can right-click on the machine setup, 2-axis inside, select geometry, shift, left-click will get you a chain. So shift, left-click will get a chain. Okay, let's go to select geometry. Let's clear our selection here. What you don't want to do, I mean, sometimes you have to, but you don't want to click around each segment of geometry like I'm doing here. You don't want to do that. You want to do a chain selection, okay? So if we do a chain selection, again, it's shift, left click, space bar will lock it in. All right. So if you're on wireframe, you can work off a wireframe, no big deal. Now, Ron had a question. When you change direction, does the offset change G41, G42? Yeah, with the wire, it does. It does change automatically for you. It knows like G41 and G42, so you don't have to think about that. See how it just says system comp on or off? So it knows what direction you're going in. So it will put the appropriate comp based off that direction. Okay, good question. All right, let's see. So we have our wire cut path here. We have our start point. We selected our geometry. So we talked about chain selecting. We talked about loop, constant Z. If you want to remove selection, you just go to the geometry, right click and remove. Okay. If you want to modify the start point, or right click reselect, I could reselect, right click, modify start point, right click, reverse direction. Okay. Is there any questions about geometry selection other than Ronald's? If there is, go ahead and ask it. Otherwise, we're going to move on to the next topic. Now, when you're looking at your wire cut, you have straight cutting, taper cutting, land and taper, coreless, and then you're going to have rough cut, tab cut, skim cuts. Okay, a tab cut might be. Can I use two stop? Can I use 2 tab cuts for a feature? That's a good question. No, not with a closed shape. It only gives you one option for a tab. If you wanted to use 2 tabs, you could combine like an open shape, so you could do it in 2 different sections. But we'll get into that some more. So you got straight cutting, taper cutting, land and taper, coreless, rough cut, tab cut, skim cut. Okay, so when we're looking at this here, this would be a straight cut right now. If we edit this feature, the wizard has all of our operations. So we have rough cut, tab cut, skim cut. Okay, I'm going to go to the machining strategy, and I'm just going to remove the other toolpath options for just a second, and I'm just going to look at rough cut. Okay, within rough cut, you have standard profile or you have coreless. If you have tabs turned on, it won't give you an option for coreless. Okay. So you have to have a tab or a tag or a glue stop turned off in order to use a coreless routine. Okay, you have corner geometry, how it handles the corners, and then you also have your leads, how it's going to lead in and out, and then you have your cutting conditions, how you're going to handle cutting conditions. Okay, so when we look at our wire here, like when we're coming down the list, you have your feature. Okay, so your feature, you have some upper guide and lower guide heights. All right, so some machines use that, some machines don't, as far as whether it's posted out or not. You have your taper settings. You have none, taper, or land and taper. Okay, here you can see you have your glue stop settings, no glue stop, use glue stop without leads. Okay, so we're going to do no glue stop. We're going to say straight cut, and we compute, and you can see we have a straight cut to run around this. Okay. All right. So now let's go back in here and edit this. Let's look at taper. If we want to add a taper, we can say whether it tapers from the bottom or top, and then you use a positive number or a negative number to determine which way the taper is going to go. So we're going to say 3 degrees and compute, and you can see we have a 3-degree taper. Let me go to like a right view. You can see that it's kicking out. Okay. If we come back and edit this and we say -3 degrees and we recompute it, you can see that it's kicking in. Okay. So positive and negative will change which way the taper will go. If we add a land and taper, we can set a taper height. We can set our taper angle, and then we can set our taper height. You do have the option to do the land and taper on the top, or you can do the land on the bottom. Okay, so we can say land on top. If we uncheck that, that will put the land on the bottom. Okay, so just a couple of different options there. Danny had a question. Usually you cut from a pre-drilled hole, as you mentioned earlier. How do you define the shape starting at a start hole? Okay, so all right, so we talked about straight cutting, taper cutting, land and taper cutting. Okay. The other one we're going to do here, we'll get rid of the glue stop. Let's see here. What do we got? No, none. Okay. Next, we go to parameters. We can do coreless, and this would give us a coreless routine. Now, this one's ridiculous. Coreless is generally we're going to use for when you have like smaller holes and things like that. And there's smaller areas, and you just want to burn out the shape versus dealing with the drop. But I did want to show the cordless. We'll go into another routine on that. All right, so let's get back to here. All right, so we're gonna do taper. And let me just delete this feature for now. Okay, so we talked about straight cutting, taper cutting, landed taper, cordless. With these routines, let's do another inside shape. Select the geometry. Chain select this next. Okay. Generally on an inside shape, you're generally going to use a stop. So I'm going to use a stop with leads. I'm going to do straight cutting. Okay. So I have my rough cut, my tab cut, and then my skim cut. So my rough cut is going to come in here and it's going to machine out the profile, and we're going to leave a tab left behind. Okay. So that the tab is going to be how much material is left behind to hold the part. Okay. When we come back and we do the tab cut, this is going to, we'll fixture the slug and then we'll drop it off. Okay. So we'll do our tab cut, and then once we get done with that, we can come back and do either one skim or two skims or three skims to dial in what's going on. Richard says, I missed it. I'm sorry, I don't know what a glue stop is. The glue stop is the material that's going to be left to hold the part in place. Okay, so see how there's a gap here? Okay, when we do our rough cut, it's starting over here. It's going to run around our shape, and then it's going to leave this little gap here. So that way the slug of material doesn't drop, okay? So that's what your tab is. Tab, tag, or glue stop, okay? I don't know what a tab is. That's what a tab is, what I just explained there. A tab, a glue stop, or a tag is all the same thing, okay? So what Danny was asking is usually you go from a pre-drilled hole. So what we're going to do is we're going to sketch up a pre-drilled hole and we're going to move it over there. Okay, so this represents the hole that we want the wire to start in. Okay, and then what we're going to do is we're going to put a point at the arc center of that hole. All right, so this point location is going to be our starting point, and then we want to lead into our profile. Okay, so one thing we need to do here is modify our start point so it's not over there, so that it's over here. Okay, another thing that we're going to do here is we're going to go to our leads page, and you'll see these all have leads options. It's set to perpendicular. What I'm going to do is I'm going to say select point, and then I'll pick points. Pick points because you may have more than one shape. I'll click on my point here, space bar. I'm going to apply this to all my operations and hit compute. And then what this does is it sets where the wire starts cutting from and where our start point is. So our start point is there on the profile, but you do have to set your lead start point where you're going to lead in from. So hopefully that makes sense. Can you use a glue stop that stops short and then continues on the profile, then skims? It depends on what, like inside, outside, and open. There's some different options. And basically what John's asking about is when you have your glue stop, what's going to happen is it's going to post up some code. So like when we look at this and we post this out, we're going to have a routine of code, and then we get this tab cut code here, and there's like offsets that are turned on and off, and different things that are happening. So one of the things you can do is when you set your glue stop, you can say don't use leads, okay, and recompute that. So what that one does is it does a rough cut. It does a rough cut to the stop point, and it stops there. Then the tab comes from that point, cuts the tab off. Then the skim cut starts. It's starting back at the center point here. It's what we're seeing on the skim, and then it's moving. Okay. If we wanted it to start at the beginning of the profile on the skim cut, you could go to the leads and maybe we could do a parallel, or maybe a perpendicular. You can have like some small amount or something, so that way it's not moving so far off. See how there's just a little bit of movement here. Unfortunately, I don't think there's a no lead. Let me see here. You have circular, You have perpendicular, parallel. I mean, I guess you could pick a point on this one and just pick, I would need to draw a point there, so let me finish that. Let me point on entity 50%, so we'll put a point there. We can come in and leads. We could say select a point, select that point, and then compute. So you did your rough cut. That went all the way around, starting from the center. We did our tab cut to cut that off without any leads, and then we did our skim cut to start from there and move on. Does that make sense, John? What he is asking is, when you do the rough cut, skim, and then the glue tab, stop and finish. I think, yeah, I'm pretty sure we're on the same page, George and John. So there's just a little bit of workflow as far as how that goes, because generally it's going to want the leads in. And so you can see the code that we're getting here. I don't know, what machine were you running, John? Let's see here. So we get our cut around. We get our tab, rough cut. Where's the tab cut? Here, what is this? This is a stop. This is going back. And then this is continuing on. I don't see the tab cut in there. You said it's a MITS. Let's switch this up. Let's go to, do you know CX, FA, H? Do you know which one? FA. All right, so let's go to that one. Yeah, so here's our tab cut. We get our stop, our tab cut, and then it finishes on. Look good? Sherman looking to do rough, trim, stop, cut, glue, rough, skim with glue stop. All right, George, hold on. We'll get to that. Okay, so we did we talked about the rough cut, tab cut, skim cut. This is a inside shape here. Went through some different workflow, posted up some code. All right, so the next thing that I want to look at here. So I talked a little bit about this one is just this one's just a straight taper. I want to open up a different file here. Okay, so now we're looking at the same thing, except this time we have a land and taper is what's going on. So we're going to run through the same process. We're going to do a new job. We'll grab up on this machine. We'll run our wizard. We're going to go ahead and pick our origin. Okay. We're going to come in here. We're going to do our 2-axis inside, select geometry, right click, constant Z, space bar, next. Okay. This one we want to do a land and taper. We're going to set land on top, taper angle, land height. We'll use our glue stop with leads. We're going to go ahead and compute. Okay. So here we can see what we have going on. Again, as far as the CAD prep, we probably would have already set where our start hole would be. Again, we're going to put a point at the arc center here. All right, we can look at editing this feature. We can go to our leads. We're going to do select point, pick points. We're going to pick this point. Okay. I'm going to apply to all operations and hit compute. Okay, so this is probably the most common thing that people run into is they go through, they set it up, they pick their point, and it's like leading into this other position over here. Remember, your modify start point, that's a separate step from the geometry selection. So let's get it over by that whole location, and then we'll see that it lines up. Okay, so again, this is going to do our taper cut, our skim cut. So we got our taper cut, we got our tab, and then we got our skim cut. Okay, so can I cut a die as a punch, first rough, then skim, then tab? You can rough and skim and tab as far as like the posting order, like which order these things cut in, and which order you do them in. But I think what you're asking is, can you keep the tab there the whole time? So let's see here. Let's look at what some of our settings are. apply taper. That's not what I'm looking for. Yeah, I'm not sure if I can leave the tab all the way and just do the tab last to have it all run through, but I'm not sure I understand exactly what you're asking there. So, but I'm going to keep moving forward. So we do a tab cut, we do our land and taper. There's 2-axis. Again, this is an inside shape. Same type of scenario here. Let's go ahead and look at this one here. Here we have a similar type shape. Again, this would be an inside shape, but I want to look at an outside shape. So I'm going to do a new job, wire job, run this through, set my 0, that's fine. This time I'm going to do 2-axis outside. So, and you know, the thing is, I've definitely gotten hung up sometimes where I wasn't paying attention to the job that I was that I was doing. Okay. So, you know, something that will hang you up is if you pick like an outside shape or an inside shape and you're trying to do the opposite, that will definitely create a problem for you. Okay. So here we have our tab. We're trying to do a taper here. Let's go ahead and edit our feature. We're going to taper the other way. You know, I'm not sure. Let's set this to, let's say maybe 5 here. We'll go ahead and compute. So obviously it's more than 5. I don't remember the exact taper on this one, so let me bump it up to 10. But you can see how you can just set what that is. We're going to lead in, cut around, and then we can do, so we do our rough cut, skim cut, tab cut. So let's look at that. So we got our rough cut. This one we have our skim cut. And then this last one here, we have our tab cut to come in and cut off the rest. Okay, so this is on an outside shape. Just setting what our taper is. I think actually maybe it was 15 here. So we'll set that to 15. Yeah, there we go. And that looks pretty good. And then we're able to run around and cut this through. So again, inside, outside, and open. I mean, we're basically inside and outside shapes really have the same options. Where things get a little bit different is when you deal with the open shapes. Okay, so let's go ahead and get rid of this feature here. And then let's look at just doing this as an open shape. So we're going to do 2-axis open, select geometry, pick this edge, spacebar, next. Okay. We have our settings here. Let me let's do taper. This is 15. I'm gonna run this through. It's going the wrong way, so let me switch it. Nope. Hold on a second here. There we go. Nope, now I have it going the other way. Okay. All right, so one of the things that I want to talk about with open profiles is when you're, let me switch this. Let's put it on the other side. So let's remove that, reselect, recompute. Okay, so sometimes what you're going to want to do here you know, is you may want to leave a tab, but a lot of times people don't, you know, they don't want to use a tab within the feature. So when you're dealing with an open shape, you can go to no glue stop, and then what you can do is use stop point. So I'm just going to sketch a point here. Usually I'm a little more little more specific about that point, but I'm going to sketch a point here, and then I'm going to select that point. So this is going to represent a stop point for me, and then I'll recompute that toolpath. And what we're going to see is this point is going to, you know, when the wire is running along, it's actually going to stop at that point, and we're going to use that as a tab. I think where I may be going wrong here is I think it may actually have to be on the profile. So let me extract the wireframe for this face here. Let me do point on entity. I can do a distance, say 100 thou from the edge of the part. Okay. Let me remove that stop point and reselect one right here, recompute my rough cut, and what you're going to see is how it creates a stop there, okay? So with the stop there, I can run through and I can backplot that, and you can see it will stop. I can get M00 or M01. This way I'm not reloading the cutting conditions and things like that. Okay, so we got our stop in there, and then we can come back and do our skim pass to have it go all the way through. So that's another way to handle that with an open shape. Okay. So we talked about straight cutting, taper cutting, land and taper, cordless, rough cut, tab cut, skim cut. We went through all of that. We're running through a lot of time. I still have all the really cool 4-axis stuff and simulation stuff to get into as well. So we talked about tabs. One of a good question that came up was multiple tabs. So one of the answers that I gave on that was, to use like an open profile. So what we might do here is, like maybe if we wanted 2 tabs within the shape, and depending on the geometry that you get into, sometimes it can get pretty complicated, especially in the 4-axis. So you may do a couple of these. What I'm going to do is just do like a parallel line here, on either side of this, like this. I'll come in and break this geometry, so I'll break that geometry where it intersects with that geometry there. What that's done is given me 2 shapes, so I'm going to copy this feature and paste this feature, and then this one I can go from here to here. That becomes, let me remove, that becomes 1 shape there, and then this one I can go from here to there. Okay, and compute that shape, and that would give me another shape there. So this way I can create, using open profiles, I can still cut closed shapes, but I'll have a little more control over where things are. Robert said 19 was much easier with tab cut for inside shape. The glue stop option set to whatever distance would automatically set a stop at a certain distance without running a whole tab operation. Basically, preset stop option on a cut profile would be a nice feature to add in the next upgrade. Yeah, I think what you saw different there, Robert, had to do with the cutting conditions that end up getting post when you use the tab cut. And there's some things that you can do in your post processor, but I think that's a really good point, something that we can add to it. Again, where things get, there are definitely advantages of some of the older wire software because of the way that it works, but there's also a lot of advantages of the newer wire software and the way that it works, and we just have to get into it. So, all right, so I'm going to move forward from 2-axis cutting, and I'm going to get into some of the 4-axis cutting, okay? If there's any additional questions about the 2-axis cutting, go ahead and make a comment into the question area so I can pick that up later and work on it. Okay, so let's look at some of the 4-axis stuff that we have. So one of the things that I thought was pretty cool is I did this this number 1 to a number 2. I thought this was a pretty cool 4-axis example, and this actually was quite a bit easier than what I would think it to be. Okay, so when it comes to this type of routine here, when you're doing 4-axis cutting, you have a top shape and a bottom shape. So, we have an upper shape and a lower shape. You also have the options for sync lines, but we've made some sync optimization or sync options that are more than just by entity. So let's take a look at what that is. Let me copy all this geometry into a new file. Okay. What I'm going to do from here is just go to a front view and select my restriction paths. Just going to put them on a different layer. So here we have a number 1 going to a number 2. We're going to run our wire job. We're going to set our 0, which really, again, doesn't really matter for what we're doing here. Okay, so we're going to blank this out. We're going to do a 4-axis outside shape. We're going to select our upper profile, which is this one. We're going to select our lower profile, which is this one. Okay. From here, I'm just going to compute the path, and the first thing we're going to see is that it's really twisted, okay, is what we're looking at. And the reason why that is when we look at the start points, they're starting from two different spots. So what I'm going to do is I'm going to move this start point over to here, hit my space bar to update it and recompute. Okay, so now that gives me this routine here. Now, you know, it's really not the worst routine. If we look at some of our syncing options, if we go by entity, if you look at this by entity, you can see that the wire is really just, there's more shapes on the bottom than it is at the top. And that's, you know, generally what you've wanted in the past was an equal number of entities on the top and bottom. Since you know, the newer wire software here, you can do this by proportion. By proportion definitely cleans this up quite a bit in order to give us a more fluid path here, okay? And then if we go by closest is another option as well. And depending on the scenario that you're getting into, it may be a combination of one or the other, depending on the geometry. In this case, I'm going to go by proportion. Now, by proportion, again, like I said, it does a pretty good job. Let's go ahead and run this through. We can see that it's going to run around. The top and bottom guide are keeping together for the most part, but there are some sharp edges that we may want to work with. Okay, so I know there's some simulation topics that I wanted to get into. If we get in here and we look at, so let's go to measure. Measure is the one that we want to get into. Measure has a bunch of different options in here. The first one I want to do is remove chips, select chips. And what this will allow you to do is use your center mouse. You can push on the stock geometry, and then what it will do is get rid of that stock geometry. Okay, so this way we can see the actual part. Let's go to a show so we can see what the part looks like. So again, using the proportion, it really didn't do that bad of a job, but we could definitely come in here and clean this up a little bit better. So let's go ahead and close this out. The next option that I want to look at is just adding some of these restriction paths. Okay, so we're going to come in here and where it says sync lines, we're going to select these sync lines. And really, I just added some in. Like if you look at it, I just kind of added some of these sync lines in that really just made sense. So we add some of those in there. We go ahead and recompute. You can see that it updates the tool path here a little bit for us. We'll come back in and run it through simulation again. And we'll take a look at how it's done. So we'll run this through. All right. Now, are you, a lot of you guys doing, there's some of you guys are still left in the meeting here, so I appreciate that, especially since it's over the 2 o'clock mark. But how many of you guys are doing 4-axis work versus 2-axis work? Do you find it's mainly 2-axis taper? You find it's more 4-axis work? What's more common in your guys' shop? George says yes. Mainly 2-axis, Danny says. Some 4-axis work, mostly 2-axis from Robert. Linda said both. John said 4-axis work, mostly 2-axis taper. Robert said 4-axis work. Yeah, so if Linda's using 19, it would definitely take you some work to get to where we are here. Okay, so let me use select chips. Again, I'm going to smash the mouse wheel or press the center mouse wheel on this stock here, and then what it will do is remove this stock so we can see the shape. So that's one of the features that I really like. I mean, it's nice to be able to simulate it. You know, the other thing that it's nice is to be able to get rid of the chips. Like the tab here, I can just center mouse on the tab, and then the tab goes away so we can see what's going on. So again, you know, just kind of this section here, I feel like I need to add another restriction line there, but just by adding some of those restriction lines, we're able to get a pretty decent path on this shape here. So let's look at that again. So we got this one here. Let's see. Yeah, we got this one here, so that looks all right. We might be able to add another one. Like we could use some of the same tricks that we used in the older version to set what the spacing is. Okay, so that's a little bit about a 1 to a 2 or a 2 to a 1. Let's see here. That was a similar type concept. Here's another one here, you know, where we have a 4-axis cut. There's a dome top surface. My center button does not remove chips. It brings up a different window. This is in the version 29, Ronald. Are you running 29 or are you running a different one? I don't have BobWire, but I've been thinking about adding it to my software. I'm still using 2016 Esprit. Okay, cool. Yeah, which button do you have that comes up when you're in there? All right, so looking at this file here, what I'm going to do is I'm just going to delete my job out of here. So let's delete this out. Okay, I'm going to start with my stock geometry. So I already, you know, milled this. If we look at this from like a right view, you can see there's a radius along the top. Okay, so we'll do new job, wire job. We're going to use the solid model stock. We're going to pick the solid model. Our 0, you know, I don't know. I'm just going to pick a corner. All right, so that's got my stock set up. So then here, this is our wire path, which I just extracted from the model. Okay, you can see the top one is curved along that shape. Okay, so we're going to do 4-axis inside. We're going to select our upper curve. This is a shift left click. We're going to select our lower curve. Okay. All the other settings, I mean, you know, we're going to keep this by proportion. We'll use our glue stop. That's fine. I'm going to go ahead and finish this. I just want to modify my start. That one looks good. And then I'll go to this one here, modify my start. That one looks good. And we're going to go ahead and compute that toolpath. You know, so pretty easy. I think what I'm really trying to show you here is that this one, the curve geometry that I used on the top, you know, I selected it how it was, and that was fine. I didn't have to flatten it or project it in this particular example. Rod had a question. Will it be on YouTube later? Yeah, we're going to send you out a recording of this session. All right, so here we can see this again. All right, so when we're in the measure, you have a couple of different options. This time I'm going to do removed auto based on volume. Okay, so I'm going to run this through. And then what it will do is drop the, oh, I think I got to turn it on. Let me turn it on and run it again. All right, so if you have removed chips auto based on volume, you can check this button on here. And then what it will do is it will drop the slug for you, so you don't have to go back and do that. That's kind of a nice feature as well. The other one here would be if we go to remove chips with test. So we'll run this through again. John, I had a question. How do you flatten top? Because on MITS you need to set Z heights on MITS FA. Yeah, I mean, you don't have to flatten the top geometry. As far as like the guide heights is what you're saying, would be based off the stock, John. So, but I can show you how to flatten the geometry. I mean, there's a number of ways to do that. But okay, so here again, this is kind of a neat little thing where you can run this test. So you're going to see whether the slug will come out or not. Whether it's going to drop, a little bit of animation, and if there's multiple parts, you can see whether it goes or doesn't go. Again, so that's a neat little tool. John was asking about how do I flatten it. So what I can do here is pull my model back up, and then I can do utilities, extract edges single, and then you have a project to Z plane. So I could, you know, set where in Z I want that to be. And when I do that, it flattens that geometry so it's flat in the XY plane, okay? At whatever Z, you could flatten it at Z0 as well. And then that way it's flat at Z0 or whatever the case might be. Does that make sense, John? I guess you could have other geometry. Sometimes, I guess, I don't know, you might use the project curves function, but that's generally how I would use that. Okay, so that's a little bit about this one. Just another 4-axis example. This was open shapes. Again, 4-axis, inside, outside, and open. I mean, you're basically dealing with the same options here. Everything that you see from the 2-axis really carries over into the 4-axis. Here's like another. This would be like another open type profile. We can go through. If there's any additional questions that you guys have, go ahead and fire it off now. Otherwise, we'll start wrapping up here. Again, I really appreciate everybody spending some time with me here today. I think I did okay covering the topics I wanted to cover. But again, there's quite a lot of products to cover, a lot of different options. So let's do 2-axis open, select geometry. I'm going to pick these edges here. Taper by some amount. All right. So again, simple stuff like this. I mean, just 2-axis tapers are pretty easy to do, so you can see what's going on. All right. I was in the wrong time zone and tuned in an hour late. Will this be available on YouTube? Yes, Brian, you'll get an email. Good job. Thank you, Danny. Yeah, I really want to thank everybody for taking a moment to spend some time with me here today. I think we did okay with the topics at hand. If there's any last questions that you guys have, go ahead and fire them away. Otherwise, we'll start wrapping up. Let's see. In 4-axis, why doesn't the start point go to where you tell it to, not the center or ends of lines? I'm not sure what you mean. Let's see. We can do this one here. So here's like a star shape. We can do our that's fine. Okay. We can do 4-axis outside, select upper, constant Z, select lower, constant Z. All right, so let's just finish this. So here you got modify start point, you got an end point, a middle point, or an end point. So we'll go, this one's a little weird, I don't know, let's say there, and then we'll go to the bottom profile, modify start point, and this one will go, you got end. Okay, so is this what you're talking about here? This may be whether you're doing, if you have a tab or not. That may be what you're dealing with there. Okay, so this one we have our start. They got them going different directions. Let's reverse, recompute. And you got your upper one there, and you got your lower one there. So that may be, why it wasn't letting you pick that same bottom edge. Was it Ronald? Because of the tab. If you have a tab there, that tab is going to get in the way. So hopefully that makes sense. All right, cool. Let's see what else we got. We got, is there a good way to get the cut length without creating toolpath used for quotes? The cut length without creating toolpath. So, let's say you had a chain and you wanted to find out the length of the chain. We can do extract edges, grab this thing here, okay? So let's say you wanted to find the path, the length of this path, without having to create the toolpath, you could select this and then do right click and do entity summary. And entity summary will give you total length of chains. I think that might be what you're looking for. Ronald said, yes, that's the issue. He said no tabs. So if we go back to this one here and we get rid of the tab or the glue stop and recompute. So you got your upper one, modify. Yeah, it looks like let's try zeroing the tab value. So we said glue stop, let's set that to 0 and go like that. Let's see if that's what it is. Yeah, it looks like it doesn't pick up that particular endpoint. It might be onto something there. All right, I'll have to look into that some more, but I believe that's what you're talking about, Ronald. Give me a yes on that or a no, so I know. Okay. All right, let's see. So we talked about finding the length. Looks like we were. George, you're welcome. Thank you so much. My FA post gives incremental sub programs. I would like G90 without subs. Yeah, John, that's if you go into your current settings, you can say, let's see here. You could say output, your subprograms, you can turn them on or off as far as that goes. And then as far as whether it's in incremental or absolute, that just may be your post setting. If you come in here, what is this, the FA? You know, if you look in here, this is absolute, so that would give you a G90. So as long as you have a G90 in there, absolute chord, then you'll be fine. So that would just be set in your post processor. So I would look at that. Let's see here. You're welcome, John. Thank you so much. Rod, yep, there's a bunch of different webinars that we've done. Okay, yes, that is the problem. Okay, I'll look into that, Ronald. I'm not sure exactly what that is. Why not set 0, of stock to the wire start point? Linda, that's actually a very common thing to do as well. Set the wire start point at 0. Really, it just depends on your workflow, so you absolutely could do it that way. Usually, like a 2-axis inside shape, I'll set my 0 for my start point, but you could have multiple cavities as well. I didn't get into patterns in today's webinar, but sometimes you'll have multiple patterns, and your 0 isn't always where your start point is. Robert had a question about that as well. Yeah, I'll definitely look into that and see what that is as far as these shapes. Let me try. Let's see what else I have here. Yeah, because on this one here, we have upper shape and lower shape. I don't have a problem with these two being right in the middle. So I'm not sure if that is some geometry condition that's causing that one on the lower guide. So I'm not sure. I'll have to find out. Yeah, I mean, you know, looks can be deceiving. Let's do 50% here, 50% there. We go to this one, you can see that one's right on 50, and you can see that one's right on 50. So those are dead on. So it sounds like it may be a geometry based thing. I'm not certain. Could be a spline curve on the bottom. That is a good answer as well. Let's take a look at that. So let's blank this stuff out here. This is a surface edge, you know. So what we're going to do is we'll convert that geometry. Okay, and then we can measure this, and it is an arc is what it is. So you would get 0.4590 on an arc. Try off of the arc on the 2. Okay, let's do that. Down for it. So let's go maybe like this section over here. So yeah, on a line you get a midpoint. On an arc you're going to get 0.4590. So that could have a lot to do with it. Like I said, geometry condition. Okay, so that one's fine. This one, let's modify the start point over to here. So if we're trying to line these two up, so we have this one and this one, you're going to see it's a little bit, I guess you have the start and the end of the arc, and then maybe you get, if there's an increment between it. Another way, like if you wanted it to start at a certain point, like what I would probably do here, let's see, so this one, so we're going to do point on entity 50%, right? So we have that point there. And then you could do break. You could say break entity, break this entity at that point. I won't do it because it's not flat. So let's I got it set to 1 inch. All right, so we'll do point incremental -1. Drop that down. Okay, we'll do break entity, break this entity at that point. Failed to break. Do line continuous. Point intersection. Okay, we do break entity, break this entity at that point. All right, so now we've broken that geometry, right? Let's get rid of restrictions. Okay, so then we should be able to reselect that, modify. Yeah, I don't know. It doesn't seem to go right there. So that's there's definitely something a little there. I don't know exactly what that is, but that's a good good little something. I'm not sure. I'll have to work through it, but I think it might be working okay. The machine may only be able to tilt the wire in one axis when entering the cut. Yeah, I mean that could be what it is as well. Let's so we got that one, that one. Oops. Yeah, but even on the start point though, let's do go to top view here. Let's go select point. Yeah, I mean it comes right over from there into that profile. So, I don't think it's a different machine or post for the lead-in geometry things that are going on there. Might be my machine will only tilt. Yeah, I'm not sure. Again, I'll look into that a little bit different. I think we're onto something there that I don't have an answer for, and I don't know that it is necessarily a problem per se. But it looks, as far as just picking where that bottom arrow is going, seems not to go where I want it to go. So, well, all right. That was a little fun little exercise. If there's anything else you guys got, we'll go ahead and answer that. Otherwise, we'll get into the next one. Again, I appreciate everybody coming around. We've been doing these really regularly, every 2 weeks. We've had a webinar, so they've been good. And, I'm happy to do them. I enjoy spending time with you guys. So thank you so much here today. And, yeah, that about wraps it up. Thank you so much, guys.